Now let's explore how to develop agents with the Google Agent Development Kit. Google ADK is built around a few key primitives and concepts that make it powerful and flexible. The agent is the fundamental worker unit designed for specific tasks. Agents can use language models for complex reasoning or to act as controllers to manage workflows. Agents can coordinate complex tasks, delegate subtasks using LLM-driven transfer, or explicit agent tool invocation, enabling modular and scalable solutions. With native streaming support, you can build real-time, interactive experiences with native support for bidirectional streaming, with text and audio. This integrates seamlessly with underlying capabilities like the Gemini Live API, often enabled with simple configuration changes. Artifact management allows agents to save, load, and manage version artifacts, files, or binary data, like images, documents, or generated reports, associated with a session or user during their execution. Google ADK provides a rich tool ecosystem, which equips agents with diverse capabilities. It supports integrating custom functions, using other agents as tools, leveraging built-in functionalities like code execution, and interacting with external data sources and APIs. Support for long-running tools allows handling asynchronous operations effectively. There is also integrated developer tooling so that you can develop and iterate locally with ease. Google ADK includes tools like a command line interface, CLI, and a web UI for running agents, inspecting execution steps, debugging interactions, and visualizing agent definitions. Session management for session and state handles the context of a single conversation, the session, including its history as events, and the agent's working memory for that conversation, the state. An event is the basic unit of communication representing things that happen during a session, such as user message, agent reply, and tool use, forming the conversation history. End memory enables agents to recall information about a user across multiple sessions, providing long-term context. This is distinct from short-term session state. Google ADK provides flexible orchestration that enables you to define complex agent workflows using built-in workflow agents alongside LLM-driven dynamic routing. This allows for both predictable pipelines and adaptive agent behavior. As part of this orchestration, Google ADK uses a runner, which is the engine that manages the execution flow, orchestrates agent interactions based on events, and coordinates with backend services. Google ADK has built-in agent evaluation, which means you can assess agent performance systematically. The framework includes tools to create multi-turn evaluation datasets and run evaluations locally through the CLI or UI to measure quality and guide improvements. And code execution provides the ability for agents usually using tools to generate and execute code to perform complex calculations or actions. Callbacks are custom code snippets you provide to run at specific points in the agent's process, allowing for checks, logging, or behavior modifications. Google ADK deploys to Agent Engine, a fully managed Google Cloud service enabling developers to deploy, manage, and scale AI agents in production. Agent Engine handles the infrastructure to scale agents in production, so you can focus on creating intelligent and impactful applications. And planning is an advanced capability where agents can break down complex goals into smaller steps and plan how to achieve them like a React planner. As part of the interactive developer tooling, Google ADK provides you tools to help debug your agents, interactions, and multi-agent systems. Your application traces will be collected by CloudTrace, a tracing system that collects latency data from your distributed applications and displays it in the Google Cloud Console. CloudTrace can capture traces from applications deployed on Agent Engine, and it can help you debug the different calls performed between your LLM agent and its tools before returning a response to the user. Finally, models are the underlying large language models, like Gemini or Claude, that power ADK's LLM agents, enabling their reasoning and language understanding abilities. While optimized for Google's Gemini models, the framework is designed for flexibility, allowing integration with various LLMs, potentially including open source or fine-tuned models through its base LLM interface. An agent can execute the steps of a certain workflow to accomplish a goal, and can access any required external systems and tools to do so. There are four main components for an agent. The models are used to reason over goals, determine the plan, and generate a response. An agent can use multiple models. Tools are used to fetch data, perform actions or transactions by calling other APIs or services. Orchestration is the mechanism for configuring the steps required to complete a task, and the logic for processing over these steps and accessing the required tools. It maintains memory and state, including the approach used to plan and any data provided or fetched, as well as the necessary tools. And the runtime is used to execute the system when invoked after receiving a query from an end user.